Zhe Zhang, who leads the Ray team at Anyscale, so the open source Ray project and the corresponding libraries. Welcome to the Data Exchange podcast.
Thank you, Ben. Yeah, it's my pleasure.
And he is also my co-chair for the upcoming Ray Summit, which we will also touch briefly on during this conversation. But first, Ray. So, how would you explain what Ray is to someone who's not familiar with the project?
Oh yeah, sure. Yeah, Ray is a general purpose framework for people to develop distributed applications. I think anyone familiar with programming would know there are two basic concepts. You can have a class and you can have a function. And Ray is a framework that makes these two basic concepts supported in the cluster environment. So Ray allows you to write classes and functions that can be scheduled to a cluster, and Ray calls it the actor and the task. Based on these two basic concepts, people can do a super wide range of things like supporting distributed machine learning, distributed data processing, and general online services and applications.
Yeah, in the early days of Ray, it was associated a lot. At least when I was when I first started inviting the Ray team to do tutorials at our AI conference, a lot of it had to do with reinforcement learning,
That's right.
and then it kind of expanded to more of machine learning.
Mhm.
So has that kind of stayed to form, Ja, or has Ray kind of broadened beyond this area around RL and ML?
Yes, I would say that the scope of the application of Ray is definitely becoming much wider. So initially, Ray's focus started with reinforcement learning. Actually, the first paper on Ray was published in 2018 OSDI conference. It's about reinforcement learning, and over the years, I think the basic reason that of the change in the scope is that initially only reinforcement learning was having a very high requirement on the flexibility and power of underlying infrastructure. But over the year, with increase of the amount of data and the flexibility of the upper level applications, this requirement on infrastructure now is becoming more generally desirable for machine learning, for data processing, for all kind of applications.
So actually, let's pivot and make things concrete by talking about three very well-known companies who have started to use Ray in production in very serious ways. So the first one is the Ant Group, which is the largest fintech company in China. So how are they using Ray? And I guess give us a very brief description of how big Ant Group is.
So the entire Ant group is, I think it, yeah, markedly. I don't remember the concrete statistics. I think it's probably the largest fintech company in the
But
entire world.
millions of transactions and millions of users, right?
Yeah, right. Especially during the shopping festival, Double 11 shopping festival. I think that's the largest shopping event in the entire world.
Right.
And actually, we're working with Ant Group to publish a blog post on how they internally use Ray for 2020, last year's Double 11 shopping festival. And I really look forward to that. So yeah, Ant Group uses Ray in a very interesting way. So they have a lot of requirement on these quote unquote fusion compute, combining the offline, the nearline, and the online. For example, they have a very large scale graph processing system, which takes data from online data sources. And another very good example is just this week, we published a joint blog post on how they use Ray for an online resource allocation application. It solves a very complex linear program problem on GPU with Ray, with data from offline, nearline, and online. And the actual service has a very high requirement on availability and latency.
So when
Yeah.
If you talk to your peers at Ant Group, um, why did they choose Ray? So in other words, I guess I remember I was struck by a presentation they gave last year where uh, in many ways I guess they can use different things to do the stuff they're using with Ray, but Ray allows them to consolidate and simplify their architecture, right?
Yeah, right. I think the key answer I would give you is developer productivity. So yeah, of course, the same thing can be done by directly using machines or even container orchestration systems like Kubernetes. But by striking the right abstraction layer, really makes the development much lower cost. For example, in the recent blog post I mentioned about online resource allocation, the same kind of logic can be implemented with much fewer lines of code of Ray. And so that means not only the initial development, but going on, the maintenance will be also much simpler. Uh, especially if the case involves online, nearline, offline. Right now, different compute engines work on different systems and really provides a potential to unify these different environments.
And so when you say online, offline, are we talking about machine learning inference? Is that what you mean by online?
It could be. It could be. So in some use cases, developers need to do machine learning training offline and do inference online, and sometimes also process streaming data. In the online learning or combining the or quote unquote lumped architecture, right? Combining the data from the data lake and the streaming data and generate the fresh results. That's one kind of use case. I think Ant Group, they do have this kind of use case. Another environment, so and also offline streaming and online can be broader, even outside of machine learning. In the recent case, blog post I mentioned is not machine learning, but is solving an optimization problem. It's a linear programming problem, but there's still a strong demand to use offline data, accumulated through a window of time, and also online data for the freshness. I think overall these requirements within and outside of machine learning is becoming much stronger.
And to emphasize, we're talking about things that they're actually using in production. These are not prototypes, right?
That's correct. Right. So in we're working on a more holistic blog post about the how Ant was using Rig in 2020 W11, and more statistics will be published there. But in the smaller, more narrow use case of online resource allocation is in production. It's actually facing external customers. For example, if you use Alipay, and this service kind of powers these external facing services, and is on the scale of over 6,000 CPU cores. It's very large scale production scale deployment.
And as you mentioned, this some of these systems were already deployed during 11.11 last year, which is 11.11 for our listeners is bigger than the e-commerce sales that take place during Thanksgiving, right?
Right. I think it's in terms of transactions, number of people involved, and revenue. I think it's larger than Black Friday. Yes.
Yeah. All right. So the next major company that seems to have really embraced Ray is Uber, and so I'm
Okay.
sure all our listeners are familiar with Uber. Um, but Uber is a long-standing tech company, so they must have had solutions and tools before Ray
Yep.
existed. So, what prompted them to consider Ray?
Yeah, I think one coherent theme I'm seeing in tech companies using Ray is the abstraction layer. Because I want to repeat what we discussed about Ant Group. So because of Ray's abstraction layer, it really enables a much better developer productivity. So in Uber's case, I think it's interesting because Ant Financial is using Ray more for flexible compute in the sense of graph computing and online resource allocation. And Uber's starting point of using Ray is much more focused on machine learning right now. So yeah, recently we published a blog post with Uber about Horvath on Ray. Yeah.
And Horovod, for our listeners, is one of the most popular frameworks for distributed training for deep learning, right?
Yeah, it supports PyTorch, TensorFlow in a very scalable and high performance way. The first part of the blog post is more technical, but towards the end, I think toward the end, where we describe the use.
Wait, so Horovod on Ray. But before Ray, they were using Horovod. So what did Ray bring to the table?
Right. So Horvath is, in terms of abstraction layer, is more of a communication framework among deep learning trainers, and Horvath needs to be supported by some lower level framework to support the execution. So Horvath currently can run on Spark, on MPI, and on different kind of backend runners. And that blog post explains why Ray is providing unique advantages. I mean, for example, one my personal favorite advantage is that there's really the first-class integration with hyperparameter tuning. And yeah, that part is highlighted like near the later half of the blog post, where we talk about a very interesting use case of Ludwig, which is Uber's AutoML solution. So through using Ray as the compute substrate across different stages of this AutoML platform, and also through the usage of hyperparameter tuning using Retune. So really, the productivity of the platform developer is much better. So most work of developing this AutoML end-to-end platform can be done using simple Python code.
So actually, Uber had this amazing quote in that blog post, which I'll read right now. They say, "We believe that Ray will continue to play an increasingly important role in bringing much needed common infrastructure and standardization to the production machine learning ecosystem, both within Uber and the industry at large." So that's quite a ringing endorsement. So so when you say that, so when they say that, so that means that if I'm using Horovod, like you said, I can still use Spark and MPI, but Uber itself seems to signal that they themselves will consolidate around Ray.
Yeah, that's the direction we're jointly going with the Uber ML team. Yeah.
Yeah. Now, in terms of the hyperparameter tuning, I will say I'm beginning to use Tune in a heavy way, and I'm a huge fan.
Thank you.
Because the API, I have to say, is quite simple, and then it also supports these different backends.
Yeah.
So if you'd like to use HyperOpt, it supports that as a backend, and so on and so forth. But it's quite simple to use, and I have to say the docs for Tune have improved tremendously. So shout out to Richard, who might be listening to this podcast.
Thank you.
So the other thing in the Uber post, and I don't know, feel free to say if none of this is public yet and you can't talk about it, but they hinted that they're actually going to do more with Ray for deep learning. So is there anything you can give us hints about?
I think, yeah, directionally, that's definitely true. Yeah, we're collaborating very actively with the Uber machine learning platform team. I think many of the audience might know Uber has a very well-known machine learning platform called Michelangelo. It's definitely one of the leading solutions in the industry.
Yeah, and it's
Yeah,
inspired basically the whole notion of machine learning platforms and also feature stores, right? So
yeah, that's
Michelangelo
right.
was a inspiration for the broader community.
Yeah, right. So it's a very if you go to Uber engineering blog, I think that is the number one most popular blog post, or either
So
number one, number two. Yeah. So it's very well known, and yeah, we're working very actively with the team to see what's the best way to use Ray. And as mentioned on the blog post, in the Uber use case, there's really unique and very significant advantage of using Ray as a common compute substrate for multiple steps of this end-to-end cycle.
so earlier you used the phrase developer productivity. So
Mm.
is this something that the Uber example is also a good example of this notion of developer productivity?
Yeah, that's exactly right. So if you think about the engineers in the machine learning platform team in Uber and beyond in the industry, so these platform engineers, they are very familiar with Python code, and they're is in contrast is not their core expertise to reason about containers and deployment, and really is really providing the abstraction layer for them to develop the logic they want to add in just pure Python code. For example, today, if a tech company is using TensorFlow for training, tomorrow, if they want to try PyTorch, then with Ray as a compute substrate, it's just a matter of importing different libraries instead of creating separate environments for these different upper level libraries.
So developer productivity because you don't have to do a lot of DevOps, IT ops kind of work, but also you're using Python and it's something that you're already familiar with. You don't have to learn anything new. Um, so that means also that you probably can use the libraries you've come to rely on.
That's
Um, and
definitely correct.
then
Yeah.
and then the abstractions that you've indicated uh, that are slightly more advanced, like actors and things like this, that used to be you had to use Erlang or something like that to take advantage of. Now you can also take advantage of, right? Um, so there are many dimensions to the notion of productivity. It seems like.
That's right. Yeah, I think when working with tech companies like Ant and Uber, we're mostly thinking about different kind of personas. One is platform engineers, another is ML or algorithm engineers. I think we're definitely improving the productivity for both. For platform engineers, I think it's allowing them to use their most comfortable tools, uh, meaning programming languages like Python, to customize their platform. Right. So for algorithm or ML engineers, I think the productivity gain mostly comes from the performance improvement and the first class integration with the rich ecosystem of free to allow them to do more. Still, I think the most obvious one is Retune, which allows the algorithm engineers to really do many more experiments with automatic optimization of hyperparameters. So yeah, we're definitely trying to make these two kind of engineers more successful.
And by the way, the other thing is you've got you basically have access to distributed computing, fault tolerance, but you don't have to worry about you don't have to worry about it, right? So
Yeah, that's right. So the Rlip team is working hard to handle all the complex cases, corner cases. So by doing that, we're kind of providing the simple abstraction to the developers. That's
so
we're really striving to do that.
I'm curious, you didn't mention data scientists.
Oh, that's right. Yeah, data scientists. So that's a relatively new direction we're working on. In recent, I would say, 3 to 5 months, we're working very actively with the data processing libraries, modeling from Intel. We also integrated ourselves, also implemented implementation of Dask on re-implementation. Another integration I want to highlight is so Alibaba has an open source library called Mars.
Right.
And the Mars team, they're working on the next major release, Mars 1.0, and that will be fully based on Rlip. So personally, I'm really excited about that. And yeah, there will be a talk in Rlip Summit about it.
Well, so
And
I guess you should probably give us a very brief description of Mars.
yeah, Mars is a yeah distributed data frame library, purely based on Python. I think in the early days of Mars, it's used a lot in scientific computing. Right now, it's becoming a more general purpose data science library.
I see.
Yeah.
Actually, this is a good segue to our next major company that has signaled that they're using Ray.
Yeah.
I was going to refer to them as a large e-commerce company, e-commerce cloud computing company, but now they have a talk that's available on the Ray Summit website, which for our listeners is at raysummit.org. But this is Amazon. So tell us about
Right.
Amazon and Ray.
Right. So yeah. So Amazon. I'm really excited about the upcoming Resami talk from Amazon. This particular use case is about data processing based on Amazon Data Lake. So as you can imagine, so Amazon, the e-commerce part, they use heavily S3 to store all different kind of structured data in data lake tables, and to power different kind of business use cases, a lot of data processing is needed, and also they have the
Define
increasing need.
define a lot.
Oh, so in this case, in this presentation, so the description is definitely PB scale, petabyte
Wow.
scale, and
That now that's a lot. Yeah, yeah, yeah.
yeah, actually multiple petabytes.
Yeah.
Right. So, for example, compaction. Right. So, and also, for example, adding simple processing for records. I think the most interesting part is this kind of data processing is becoming, they are having a higher and higher requirements on the flexibility. Yes.
So this kind of scale of data processing, would it be fair to say that many people will first use Spark?
Yeah, definitely. So Spark, I think if your data processing need, if it's very much SQL style, I think Spark is definitely a leading solution in open source. So I think yeah, Amazon is using Ray for this use case because of the flexibility.
And the Python is their mode for data processing.
Yeah, and also from the layer of abstractions, Spark is a data processing library, is higher level abstraction than Ray. So
I see.
to illustrate these from another angle, Intel has contributed a project called the RayDP, is running Spark on top of the Ray layer, right? So in
So
the sense
the
that
key point there is that they're using Array for data processing at petabyte scale in Python,
Yes,
using familiar APIs. Which, by the
that's
way, before we dive even more into Amazon, you folks wrote a blog post about Ray and data processing.
actually two of them. One
Yeah,
is
sure. So give
yeah,
us kind of a brief summary. What's the lay of the land in terms of data processing in Ray? What should people use?
yeah. So that's a very interesting question. I think my summary is that Ray itself, we want it to be the unified memory layer for different data processing libraries, and we definitely, I think
So
we
you folks yourselves are not creating your own data processing library, right?
right, not at this stage, because we understand a data processing library is a lot of work, it's a lot of investment, and also, to be honest, the requirement and people's preference for data processing libraries is there's a lot of diversity.
Right.
Um, so many data engineers, for example, they prefer Spark, and we also know that among data scientists, pure Python libraries like Dask, Modin, Mars, they are
Pandas.
more,
Yeah,
yeah,
yeah.
pandas, yeah, they're more popular. So I think the best strategy for the Ray team is to focus on making the Ray layer very solid. For example, the object store. We want to make sure the object store is a really good solution for shuffling data, and then make the life easier for library developers, make them more successful in developing libraries easily.
But the bottom line is, let's say I'm a developer who wants to do data processing in Python at scale. I can use Ray alongside many of the libraries I have come to use, right?
Yeah, if you want, you can even use Spark and Modin in the same Python code and mix their data. Um,
I see. Yeah, yeah, yeah.
yeah,
So which of the libraries that so what are the common data processing libraries that Ray users use?
great question. I think I've definitely heard people using RDP and Dask on Ray.
I see. I see.
Yeah, Dask on Ray is a good solution for feature engineering, feature data processing, and yeah, RDP. I think it could come very handy in the more ETL style data processing. And I'm also really looking forward to the Mars 1.0 release.
So I'm looking at the description of the Amazon talk at raysummit.org.
Mhm.
They mention Ray, Arrow, and Parquet
Yeah,
at petabyte scale.
yeah,
Um, yeah, this is impressive. So the nice thing about it too is that these are file formats that people are already familiar with, right? Like, for example, Parquet.
yeah, yeah. Yeah. So I really like these. Yeah, thanks, Ben, for mentioning Ant Group, Uber, and Amazon. The thing that I really like about these three very heavy production use cases is that they're stretching the limit of Ray in different dimensions. Uber is really pushing the limit of Ray in terms of offline machine learning, in training, classic ML, and deep learning, and hyperparameter tuning. And Amazon is really pushing the limits on Ray on heavy load, really heavy load data processing. For example, they're accessing the object store very heavily. And Ant Group is pushing the limits on the sheer scale and the flexibility. They're using Ray to do many kind of compute that combines different environments. So I think, yeah, altogether, I see a very exciting future for how people can use Ray.
So actually, so this is a good segue because you talked about how these three companies have variety of use cases and
Mhm.
workloads. Um, so let's talk about libraries then. So
Mm.
let's say I'm not familiar with Ray and I want to start using it. As we mentioned, chances are if you're a Python developer, you can use any of your libraries with Ray, right? So in fact, Ray might even have integrations and directly with your library, your favorite library, and scale your favorite library, right? So
Yeah.
give us a sense of so the libraries that you folks create and maintain, and then the ones that you have maybe direct communication with, uh, as far as direct work integrating with Ray.
Yeah, sure. I think I want to mention three libraries that Ray team maintains. One is I already mentioned Retune is a leading solution for hyperparameter tuning. And yeah, actually, before Anyscale, I was at LinkedIn, big data and machine learning computing. So the, at that, so our team was using Retune for tuning model hyperparameters. And a less known fact is that some people also use Retune to tune different kind of parameters. Recently, I've heard people wanting to use it to tune the job parameters for example, Spark, amount
Oh
of
yeah, I mean,
memory. Yeah,
it's definitely very flexible and powerful. There's nothing that limits it to ML.
yeah,
Yeah, yeah.
right. Yeah. So the second library I want to highlight is reinforcement learning, Rlip. If you go to rlip.org, you can see the library is, I think in my mind, is a, yeah, it's a leading solution for scalable reinforcement learning. And I
And
personally
and
am,
and in fact, I think uh, we have several presentations at raysummit.org about
yeah,
reinforcement
yeah,
learning.
I'm very excited to see the real world application of reinforcement learning. Because as compared to classic machine learning and deep learning, reinforcement learning has uh, architecturally, it has a lot of promises. I'm really looking forward to those getting realized in use cases in manufacturing, in logistics, and in gaming and beyond. The third library I want to highlight is Reteam is also very actively working on services or a model serving. So there's a library called Reserve, and the team is investing very heavily on revamping the APIs to make it more general purpose, easier to use, including the documentations. The yeah the recent the Ant group blog post I mentioned about online resource application, architecturally it uses a lot of components of spinning the live reactors to serve online workloads. I think that's there's a lot of space that we can develop in serving. Yeah, those are the three native libraries I want to highlight.
And then let's say I'm in Python, working in data science and ML, and some of my favorite libraries are scikit-learn,
Mhm.
XGBoost, Spacey, Hugging Face. So I can use and scale all of those with Ray, right?
Yeah, that's definitely right, Ben. Right. So, there's a pretty popular integration of secular on Ray. Again, that's the great work from Richard. It even predates me. I think the main work was done before I joined Anyscale. The one I did experience is where the team integrated XGBoost on Ray. XGBoost is used very heavily on tech companies like Uber and LinkedIn.
So
Yeah.
again, what's the benefit for an XGBoost user of this integration?
So I think number one is XGBoost itself is a native library. Is There's no JVM. XGBoost itself is plus plus and Python. And uh, okay, I think there was a brief disruption of the network. XGBoost can be distributed in different ways. At least from my experience at LinkedIn and the experience we have with the Uber ML team, in large scale deployment, currently the most popular way is to run it on Spark. Um, I think a couple of years ago, Uber also has had a blog post of running XGBoost on Spark. So this introduces the overhead across JVM boundary. And also, so it's not only the performance, but also based on my experience at LinkedIn, fault tolerance will also be a challenge because many common errors cannot be propagated across a JVM boundary. And also Spark's support. I mean, I think yeah, just fundamentally because Spark started as a data processing library, so the support for GPU came quite late. It's only in Spark 3.x. So many large-scale deployments they couldn't easily leverage GPUs. And then I would say the Ray backend for XGBoost also has yeah really good support for hyperparameter tuning. So in summary, I think performance, fault tolerance, GPU support, and tuning. Those are the four main benefits I see on XGBoost and Ray.
So, any quick update on Ray for NLP users?
Yeah, I think the most exciting update I have seen is is a new architecture in Hugging Face called Rack. Is for I think it has a requirement to flexibly retrieve documents and then do training. And yeah, recently there was a collaboration between Hugging Face, Anyscale, and Facebook Research to implement Rack on Rlip. I think whenever there's a need to do this kind of flexible or fusion compute, RE has the advantage of again developer productivity. Is I think overall is the more kind of things you do on RE, the more benefit you have. Right? If you have a very simple like uni-purpose workload, then the benefit is relatively smaller. When you want to do more end-to-end uh, compute, then it's becoming more and more obvious using Ray will reduce the complexity of development. Actually, so for many library integrations, this simplicity was also pretty obvious. The integration of attributes and Harvard on Ray. So initially, when I look at code, I was pretty amazed. The complexity of code supporting attributes and Harvard on Ray is much simpler than other backends because again because the Ray is basically providing very natural abstractions, the classes and the methods, right? So when doing machine learning training, it's very natural to use the Ray classes and functions to to distribute the compute to the cluster. With other frameworks, the complexity is much higher.
Okay, so we've covered kind of some uh, very impressive use cases and users of Ray, the current state of libraries. But since we have you on the podcast and you are leading the open source team uh,
Mhm.
on Ray, so give us a sense of the near term, some highlights for your near term roadmap. So I'm thinking 6 to 12 months. So what can users look forward to?
Yeah, so it's a great question. But yeah, on roadmap, definitely. Number one is we want to ensure there's successful resummit. So technically, I would say in the near term, our focus is to make Ray the unified compute substrate for machine learning platforms. I think in the very beginning, I think you had a good question of in the time horizon how Ray is being used. In the beginning, it was reinforcement learning, and over time is expanding to machine learning in general, and over time it will become more general purpose. I think we're at the stage of focusing on Ray for machine learning platforms, because as I mentioned, if you do multiple things, then the advantage of Ray being the unified compute layer is more obvious. And machine learning platform is such an interesting use case, which requires different kind of compute workloads to do machine. So typically, it starts with managing of processing the feature data. That's very classic data processing need. And as I mentioned, we recently integrated a lot of data processing libraries, Dask, Modin, Mars. And then there's the training and hyperparameter tuning. And then oftentimes you need to do offline inference and online serving. With Ray, we really hope to provide the platform engineers the we really want to empower the platform engineers to customize the platform for each one of their companies, right? Being it agriculture or social network, right? You want to provide them a place to do all these three, four different kind of things easily. So that's a near-term focus. Um, yeah,
And
to
then
do
and
that,
then
yeah.
and then I guess to that end, the fact that the three examples we cited, Ant Group, Uber, and Amazon, these are big companies who are
Yeah,
doing something along the lines of what you just described, right? So
yeah.
there's validation that this open source technology can live up to this expectation.
Right. Yeah, I think they're very interestingly these three very successful large scale users. They're moving toward different directions. I think the Uber case, they're more kind of revamping the current ML platform based on Ray. In the Ant case, they have very successful deployment of Ray in non-ML use cases, and they're trying to move to more machine learning already. And yeah, similar for Amazon. They're kind of going from successful data processing to exploring doing machine learning already.
By the way,
Yeah,
at the Ray Summit, there is a talk from Amazon researchers about how they're using Rlip for training robots.
yeah, that's right. I'm very much looking forward to that. I think reinforcement learning on Amazon is exciting because is really the multiplier, right? So on Amazon, either SageMaker or other platforms, whatever the usage of RLE is easily accessible to a large number of developers and machine learning researchers.
By the way, I don't. We didn't expect that we would forget to mention this, but we have, which is one of the best talks at raysummit.org, is a presentation about how RLib was used to design the winning boat for the just concluded America's Cup. Yeah.
Yeah, that's an amazing topic. So I was really amazed when I saw the news. I so personally I'm from a big data and infrastructure background. So for me, the most exciting thing about working on Anyscale and Ray team is to learn this cutting edge usage of machine learning. I think reinforcement learning is definitely on the front end of applying automation and machine learning for very interesting use cases, including the sailboat use case Ben just mentioned.
All right, and with that, thank you, Ja, and we look forward to meeting all of you at the Ray Summit, which is coming up June 22 to 24. It's free, it's online, um, and you can find more details at raysummit.org. Thank you.
Thank you, Ben. It's great talking to you.